Hi, I'm Cheryl Leach. In this problem, we're going to be finding an indefinite integral. Now, one of the challenges of integration is to decide which technique I'm going to use to integrate my expression. Well, this gets more and more difficult as our integrands become more and more complicated. So let's take a look at some of the options that we have so far. One option are to use some basic rules. But in this particular case, my variable is in the denominator, and so those basic rules are not going to be very helpful. All right, well, we've also done some problems where we've been able to rewrite the integrand using some algebra. And when I do that, all of a sudden I can use my basic rules. Well, let's try to think ahead a little bit on this one as well. I could write this as 2 times the quantity 3x plus 5 to the minus 1 power, and then try to use my general power rule. But remember, if I do it that way, my exponent's going to be -1. And the power rule is not defined when that exponent is -1. Think about what would happen. You have to add 1 to the exponent and divide by the same number. -1 plus 1 is 0. You'd be dividing by 0. So that's not going to work either. Well, let's take a look. We don't normally think of a division problem as being a composite function, but we can think of composing 3x plus 5 with 2 divided by x. So if you think of it as a composite function, then the U substitution technique becomes available. Well, my other options have failed, so let's give that one a try. So let's let U be the inside function, which is going to be 3x plus 5. So if I were to put this into my integral, I'll have 2 over U. But then I still have a dx floating around. So I need to find the relationship between dx and du. So I know that du dx is going to equal 3, which means that du is 3 dx. Now, I don't have quite the right relationship here because I only have a dx. But we fixed this before. We're going to multiply by 3 and multiply by 1/3. So I'll rewrite my integral as 1/3 times 2 all over 3x plus 5 times 3 dx. Now I notice that this piece can be written as 2 divided by u, and this piece is my du. So my integral looks like the integral of 1/3 times 2 over u times du. Well, I have a constant of 2/3 that can be pulled out. And my integral becomes 1 over u du. Notice I've eliminated all the x's, so I should be able to integrate this. This is where our newest rule comes in. What is the integral of 1 over u du? It's the natural log of the absolute value of u. So I have 2/3 natural log of the absolute value of u plus a constant. And as always, integration's over, so I need to get my x's back. So I'll have 2/3 natural log of the absolute value of 3x plus 5 plus a constant. I hope this is helpful. Thanks.